This conference will now be recorded.
Hey, hello everyone. A very good morning. Continuation to the yesterday session. Today, I will try to understand about one more very important concept called encryption and decryption using SSL or TLS certificates. Right. So, as you guys already know, in last three sessions, we started discussing about very important concepts. So, as part of the I mean to say first session, I mean to say in this series, part one, we discussed about what is a load balancer, what is reverse proxy, what is the differences between the load balancers and reverse proxy, which one can be used in which use cases or scenarios. And we discussed about the types of load balancers based on the implementation, based on the OSI layer that we are going to configure. There are categorized hardware load balancers, software load balancers, and cloud managed load balancers based on the implementation and based on the layers in OSI model. Based on the layers that the load balancers operate, also they are categorized like layer 4 load balancers are a network load balancers, and the layer 7 load balancers are called as an application load balancers. Whether we are using a software load balancer or a hardware load balancers or a cloud managed load balancers, we can configure a load balancers at OSI model layer 4 or layer 7. And using Nginx in the next series, I mean, say in part 2, we discussed about what is Nginx and how we can use Nginx as a load balancer or a reverse proxy to our applications. I mean to say, application deployed in multiple servers. We have taken Java based application that we have deployed in Tomcat behind the Nginx, and how we can use that Nginx to distribute the traffic and load balancing algorithms, all those things we have discussed. As part of part 3 session, we discussed about what is DNS, why do we need DNS, what is domain, what is DNS, how DNS works, how to register the domain, and how we can map the domains we have discussed. So continuation to that, the next very important concept is security, securing the data that is exchanged between the client and server, right? So we'll try to understand that part in today's session. If you see, I have a already uploaded those three parts into our YouTube channel, because these are very important and it will help the community also, the community people who already has some knowledge. But without all other concepts, like in this sessions we also used AWS, we also discussed about VPC networking, we used, but without that knowledge, the other people may not able to understand, but at least they should be able to understand what is load balancer, reverse proxy, DNS, and security. So if you see, this is like a part 1 session, this is like a part 2 session, and this is part 3 session. So in continuation to these sessions, we'll try to understand about our security concepts now. If you see, in my AWS account, I have a servers. I have created few servers where I have deployed one application in multiple servers, and I have a load balancer also created using Nginx. But as of now, I have shut down all my servers. Let's start all these things. But some concepts has to be, you guys remember, private IPs will never change. Uh, in that life cycle, in that EC2 life cycle, right? Unless until you are going to terminate and create a new instance, the private IP remains same. But these application instances, anyhow, they are in a private subnets. We don't have any public IPs, and I am using these private IPs only in this load balancer, the load balancer upstream I have mentioned the private IP is fine. And also in this servers we have installed Tomcat, and we have enabled Tomcat as a service on Bootstrap. Suppose if I stop and start the servers also, Tomcat will be started automatically in that already application is also deployed. And in this Nginx also, we have installed that Nginx software, and we have enabled that Nginx service also on a Bootstrap, and we have configured Nginx also as a Nginx enabled on Bootstrap, so that Nginx also will be started. And in that Nginx, we have configured the reverse proxy rules. In the Nginx conf file, we have mentioned if any request comes to this load balancer on port 80, forward that request to the upstream servers on 8080 like that. But the problem here is we used a domain. But as of now, I have not allocated any elastic IP to this load balancer server. This is normal public IP. Suppose if I stop the server and start the server, this IP will change. And this IP I have mapped in my DNS. In yesterday session, we have mapped that domain, right? In actual DNS like Route 53, I have mapped this IP with my domain, right? But now if you try to access, since IP is changed, it will not work. Suppose my domain, you guys know, right? Yesterday www dot. This is additional domain where I have used. If you see, maybe even though I use my application context, it may not resolve to any IP. If required, you can use some kind of a commands also for trying to find out, because that it is going to result to some IP, but that IP is not in use now. That we stopped and started different IP. So maybe if you are using local host file, if you don't have a domain, this IP you can go and modify in your local laptop host file, as I said in yesterday session. Otherwise, now I am using a real DNS in Route 53. I will update my record, A record or alias record. Basically, we are going to use A records to map to the IPs, right? So in this AWS Route 53, I have created a hosted zone for my domain. Here already I have a name servers. These name servers I have updated with my DNS provider, that is Hostinger. Now here I will update. This is a pointing to different IP, but now this load balancer IP is different. If I go back to EC2, you can see this is different IP. Let's take that IP. Let me switch to Mumbai region. Let's take this IP. I will update that here. Here, this domain I have mapped to this IP. Let me edit this. Let me save this. Similarly, this www also subdomain, right? Also, I have mapped to that different IP. Now, let me update. Now, you see, this will result to that IP, and we will be able to access that application. But it will reflect us. It will take some time to reflect immediately, maybe just a few seconds or few minutes, right? But in real time, you are not going to shut down your servers. Even though you shut down and restart, maybe you will use that elastic IP. Elastic IP, that is a static public IP. Elastic IP, fixed IP. Even though you stop and start, it should not change. So now I have given this updated IP. It will reflect in some time. Let me use Control Shift R. If you want, you can look into this DNS, that NS lookup or a dig also, something like this. it will resolve, but make sure we are using HTTP. Still HTTPS we have not configured. So now if you use HTTP protocol, it should resolve. Okay, maybe it is still taking HTTPS. Maybe you can use a browser, you can delete the cache, or you can open an incognito window, something like that. Okay, so let's use HTTP protocol, then it should work. But if it is redirecting to HTTPS because of cache, what you can do, you can clear cache, since we have not configured HTTPS, otherwise you open incognito window. Now it is working like this. Now it is working like this. Now if you see, we are able to access that application now via load balancer. But here if you see, browser is saying this connection is not secure. It is saying connection is not secure, not secure, right? So here, don't give sensitive information like that. It is giving some kind of a error. Suppose you open any browser, right? Maybe Chrome, Mozilla, Firefox, Safari. If you try to open that URL, it will give some kind of a message also, warnings, browser. If you see here, it is saying, it is going to say, 1 second. Browser will say it is like not secure. You can see here itself, not secure. Like that, the browser don't enter any sensitive information like that, they're going to complain. That is because the data, as I already said in yesterday session, the data is being exchanged in a plain text format from this client to the server. So how we need to secure this? Here we have a concept of encryption, decryption, like that. Encryption, decryption, like that. Now if you see here, it is saying not secure, like that. And here some kind of information, whatever we are going to give, that can be some kind of a usernames, password, payment details, like that. When the data is being exchanged between this client and server, as I already said, there is a man in middle or middleman attacks, there is a possibility. Let's imagine this is my systems, these are the systems, right? Basically this is the client or a user. This user is communicating with this server. This is called as a client system. This is your server. This server can be directly the server where your application is deployed, or this server can be a reverse proxy instance. That application is actually deployed in this server. This application is internally passing that data to these servers where application is deployed. And these servers can internally talk to databases again, a typical three-tier architecture. But now these are like a private instances, private network, but the data exchanged from this client to this public instance, this load balancer in the internet, it is going in a plain text, especially that is not recommended. There is a possibility that right, there is a middleman, man in middle or middleman attacks, we call it man in middle or middleman attacks, we call it. So this person will be able to understand what communication is happening, what data they are being exchanged. So if it is working on HTTP protocol, if it is exchanging the data using HTTP, hypertext transfer protocol, that is a protocol is basically a set of rules basically used for exchanging the data in the network. We have different. So this HTTP and HTTPS protocols are used for applications, so especially web applications. That can be a static web applications or a dynamic web applications or a REST APIs. The data will be exchanged, or the client and the systems or applications can communicate using HTTP or HTTPS. If the data is being exchanged using HTTP protocol, whatever information is being exchanged from these two, it will go in a plain text format, normal plain text format. So this is going to be exchanged in a plain text. Whatever data this user is submitting, and whatever data this server, this application is giving back to the user, right? It is going to be exchanged in a plain text format. So if it is exchanged in a plain text format, right, this person, especially the man in middle, MMA, this person also will be able to understand in the network, especially public network, when the data is exchanged, they can easily understand what type of data they are exchanging, they are sharing. So that is very risky. So this is where we are going to use something called encryption and decryption. Encryption and decryption. So here there is some kind of a concept called encryption. We have to encrypt the data and send over network. Then they can decrypt the data. So there is a concept called encryption, decryption, using algorithms, using some kind of algorithms. There is a concepts, right? Plain text will be converted into a cipher text. That cipher text is nothing but basically cipher text is nothing but the data, if it is encrypted and sent, that is called as a cipher text, right? So we have something called cryptographic algorithms, right? So using some kind of algorithms, that cryptographic or encryption algorithms, basically the plain text will be converted into a cipher text. Cipher text is nothing but the original data is going to be encoded or encrypted into different format, that is called as a cipher text. So here there is a concept of encryption, decryption, use symmetric encryption, asymmetric encryption, and again this encryption will happen, decryption will happen using some kind of a cryptographic algorithms. We have some kind of an algorithms, right, or a keys like that. So we will try to understand basically what is that cryptography, symmetric, asymmetric encryption. So in cryptography is basically one kind of a mechanism or a algorithm. So here cryptography is like a process of hiding information that only the person a message was intended to be read, only they can understand the data. Basically, cryptography is a technique of securing information and communication using some kind of a key, encryption algorithms to prevent unauthorized access. So here, like a secret codes, this is secret codes, right? If you see in old movies also, if some person has to share some kind of information, they will use some kind of a secret code, right? So same concept here, right? So here, this cryptography is the practice of encoding and decoding the data to prevent unauthorized access. The concept is existed even for thousands of years also. So here, this cryptography is like it's one process or a concept of encoding or encrypting and decoding, means decrypting the messages, the data, basically to prevent unauthorized access. So cryptography uses some kind of an algorithms, mathematical algorithms. So cryptography uses some mathematical algorithms to encrypt and decrypt the data, ensuring secure communication and secure data exchange. Secure communication, securely the data is exchanged over network. Basically, this cryptography uses some kind of an algorithms to encrypt the plain text data to the cipher text. Cipher text is called as an encrypted text. So again, that encrypted text will be sent over the network, and the actual system or actual system who is intended to receive the data, they will receive that encrypted text, and they will decrypt that cipher text will be again converted into a plain text. Suppose this plain text is converted into a cipher text is called as an encryption. That cipher text is again converted into a plain text is called as a decryption. But this encryption and decryption will happen using something called keys. We need a keys to encrypt and decrypt. Here we have two types of keys, no? Encryption concepts, basically symmetric encryption, asymmetric encryption. So symmetric encryption, both sides the same key. Both the sides we are having a same key, single key. In symmetric encryption, let's say we have a only one key. Suppose that is a old approach. There is something called keys, keys to encrypt and decrypt. Let's say, imagine if this we are using symmetric encryption, then this client, a client is nothing but a browser. Client is nothing but a browser. This client is nothing but a browser. So this browser is basically that system, this client, this system, it will use some key and it will encrypt that data, that plain text, whatever we are giving, that will encrypt that text into a cipher text, basically using this key, and it will send the data in not in a plain text format, in a encrypted format. It will send, instead of plain text, a cipher text. The cipher text is nothing but a scrambled or encrypted text. But here, this server or this application cannot understand the data whatever is sent in a this encrypted format. This has to decrypt the data. But this in order to decrypt this data, in order to decrypt this data, this server also should have the same key. If it is a symmetric encryption, here only there will be only one key, only one key. And in this case, this person, this client also has to send this key over network again. This client also has to send the key to this server. Then only this server can again convert this ciphertext into a plain text. Again, it will convert that ciphertext into a plain text again. Otherwise, the server cannot understand again what type of data you have sent. But in this symmetric encryption, we are using only one key, and again, this key has to be transferred in the network. This key has to be transferred in the network. Maybe this person is going to give the key, and using this key, this person, maybe this server also, this server itself can give the key to this over network, and using this key, this client will encrypt the data, and again it will send that data in a plain text. But either this party is sending the key over network, or this server is sending the key, or client is sending the key over network, but again, key also has to be exchanged in the network. But imagine if a symmetric encryption, if symmetric encryption used the same key we are using for encryption and decryption, both the same key. In this case, there is a possibility of this, security compromise will happen here again. Suppose again the key is being exchanged over network. This person, middleman, also can get this key. When the key is exchanged in the network, again this person also can get this key, right? Either the client is sending the key to the server for decrypting the text, or maybe server is sending that key to this client to encrypt the text. When the network, in the network, if these keys are sent, again there is a possibility that this person also, this middleman also will have the key. In that case, again, even though this person is encrypting the text using this key and sending, this encrypted text he can get, and he also has a key. So he can decrypt the key. Again he can decrypt the text and understand. So this is not again going to work out unless until you are there is a way to securely again transfer the keys. This is not secure again if there is a way to securely exchange the keys, again this is not going to be secure. This this asymmetric encryption, this is not going to be secure again unless until there is a secure way, securely you are exchanging the keys. This is not going to secure again in this symmetric encryption. So there is a one more concept called asymmetric encryption. And again, this symmetric encryption or asymmetric encryption, basically again they are going to use some kind of algorithms to encrypt the data. Algorithms, like AES algorithms, for asymmetric encryption, RSA algorithms, like that. There is a algorithms with some kind of a mathematical algorithms are used for encrypting, decrypting the data. Basically, ciphertext, scrambled text. Basically, here symmetric encryption. Symmetric encryption. A single key is only used for encrypting as well as decrypting, and this is little faster, and it is going to make suitable for encrypting a large amount of data. But again, when the keys are, this key also has to be exchanged over network. If there is no way you are securing, you are securely transferring the key, again there is a possibility of this middleman attacks. So this is where again another algorithm, I mean to say another type of encryption is there, asymmetric encryption. In this asymmetric encryption, symmetric encryption, asymmetric encryption. So here symmetric, there is something called asymmetric. Asymmetric. So in this asymmetric encryption, basically we are going to use a pair of keys. Here there are two keys. There is a concept of public key and private key. So public key is used for encryption and private key is used for decryption here. This asymmetric encryption uses a pair of keys. Basically, we will have a public key as well as private key. Private key. So here basically in this this public key is used, it is used for encrypting the data. It is used for encrypting, encrypting the data. And again this is used for decrypting the data, decrypting the data. Again it is used for decrypting the data. Encrypting and decrypting, asymmetric encryption. Here we have some kind of an algorithms, RSA algorithms, like that. So here, if I am using asymmetric encryption, here we have a keys. Suppose here I will have a key, two keys, like a public key, private key. Here I can generate. Here I can generate a keys. There is a open SSL. There is a one concept called open SSL. Using open SSL also you can generate the keys. Using, there is a CLI utility called OpenSSL. Using OpenSSL, you can generate the keys, a combination of public key, private keys, like that. You can generate the keys. Let's say here you have a keys. Here you have a keys, basically public key, private key. This server side, you have a public key, private key. Let's imagine. Let's imagine you have a keys. Let's say here, imagine this is a private key, and similarly there is a public key. Similarly, there is a public key. Imagine this is a server. This server public key, private keys, like that. We can generate. We can configure here. We'll discuss about that. Let's say this is your server. Let's say I am saying yes, server private key and server public key. Server private key and server public key. And again, I can configure these keys here. And any request comes to this client. I mean, say any request comes to this server. Any request comes to this server, I can tell I wanted to communicate securely using these keys. I wanted to communicate this securely using keys. Here we are going to tell I don't want to, this server can say I wanted to communicate with HTTPS protocol instead of HTTP protocol. In case of web application, HTTPS and HTTP. So HTTPS stands for Hypertext Transfer Protocol Secure. This hypertext transfer protocol secure. Basically this https internally uses something called a TLS or SSL protocols. TLS or SSL protocols, and that the keys are certificates. We call it as a certificates or a keys. This https internally uses something called SSL and TLS protocols to encrypt the communication between the web browsers and servers. This HTTPS is especially securing web connections, web applications, this HTTPS. And this internally uses a SSL or a TLS protocols, and that keys are a certificates to encrypt the communication between web browsers and servers like that. It will ensure the data transfer during browsing, like we are going to use web applications, web browsing, right? It is going to secure the data and encrypted and sent. Here, whenever any request comes to this server or that application, basically, this can say I wanted to communicate with HTTPS protocol. We are going to use HTTPS, Hypertext Transfer Protocol. And again, it is going to tell, so this is my public key. It is going to give, okay, this is my public key. This server is going to give the public key. It is going to exchange in the network, fine. But this public key is used only for encryption, not for decryption. Even though this middleman can get that public key, that is of no use. What is the use of this public key? Only for encrypting. This public key, the server public key, when any client is accessing that application, if it is configured to use HTTPS protocol and using these keys or certificates like that, then the server will say, I wanted to communicate using HTTPS. This application or a server will say, I wanted to communicate using HTTPS. This is my public key. You use this key. In the network, it will send. It will send this in the network. And even though there is a key, even this person also can have the key, middleman. But this public key is used only for encryption. So this user or this browser will use this server public key. This S public key means server public key. It is going to use this public key, right? And this browser will convert that plain text into a ciphertext encryption. It will encrypt that plain text into a ciphertext using this public key. Then the data will be sent, the encrypted text will be sent, or cipher text will be sent over network to this one. But even though this person also have a copy of that cipher text, that is of no use, right? Because this person don't have that respective private key to decrypt this data and understand. Even though he has a data, but that is cipher text data, not plain text data. That is a ciphertext data, not a plain text data. But in order to convert this ciphertext data, in order to decrypt this ciphertext data to a plain text again, this person should don't have a private key. So that is of no use. This person can't do anything here. But now this server has a respective private key, and using this private key, this server will do decryption. This server can decrypt this ciphertext to a plain text, so that this server or that application can understand what data is being sent. But still, this is a here also there is a possibility of still security issues are there here also. There is a concept called proxying or a phishing phishing websites. You might heard something called phishing websites. The people can act as a proxy also in between. These type of hackers can act as a proxy also in between. So they are going to develop a phishing websites like exactly same, exactly same. Our website, however my website looks like, similar type of website also they can develop. So they can do some kind of a middleman person, middleman or a proxy role also they can do. So what happens, right? The request itself they can bypass. So what they can do, when any request, if this person is trying to access this application, this server or this application deployed here, maybe this person can mimic some kind of a phishing activity. So request, instead of directly going to this middleman can take the request using phishing websites. It is like exactly looks like same. And what this client will think, I'm actually working or using the real application. But there is a possibility that this user may think I'm actually interacting with the actual system or actual application, whatever I wanted to interact. But here there is some kind of a phishing websites if you see nowadays brands, like if you go for water, right, we have something called a Bisleri. Exactly same look and feel, bottle size, bottle style, exactly like Bisleri, but there is something called Bislane, something like that, a name, that name. But exactly by looking at that water bottle, you can think that is Bisleri water bottle only. But the exactly look and feel is same, brand name is also almost the same. So that is called as like a making the customers or users a fool, right? Same way here, this middlemans or hackers can develop the phishing websites. It is exactly looks like same, but a little difference. Now, same like Rushi Technologies, Rushi I Technologies, right? If you see, this is my original website. The domain name is also www.rushitechnologies.com. This is my actual. Let's say you are a student. You are a student. Your expectation is you wanted to interact this application, but same way. But there might be some look and feel also they can develop like this. But here Rushi some additional like this they may have. But look and feel is same. But when you are interacting, you thought you are interacting with this application only, but this is kind of a phishing website. So they can do this type of bypassing that request also instead of this, right? They will take the request to their systems. They will take the request to their systems, and this person, let's say this person also will have a keys. This is your actual system key, but this is, imagine this is like a this system. This also they will have their own keys. They will have their own keys, this is like a hacker private key, hacker public key. This is not your actual system keys. So when they are going to act as a proxy here, phishing, so you are thinking you are accessing this application as a user, but no. What happens, right? They will try to bypass this. They will try to bypass this. Maybe you are interacting with this application, and this person will give his public key to this client. So now this client instead of this public key, maybe this public key will go. This public key will go here. This public key will go. Now this hacker public key will go if they are doing that type of phishing activities, right? Then you are thinking you are interacting with this system, this application, but no, you are interacting with this system, this person's system or something else like that. Now you are encrypting the data using his public key, then you are sending, right? You are submitting. Then he has a private key, he can decrypt. He can decrypt whatever data you are giving, he can decrypt here. Then he can interact with this server on behalf of you. He can interact with this application on behalf of you. This also thinks, this server also thinks this is also one type of customer only. So what he will do, he will, this server will give his public, this public key, this public key for encryption. And whatever data this person got from you and decrypted using his key, same data again he can encrypt and send to this server, and they can access the application on behalf of you. So here also there is a problem. Here also there is a problem, even though you use this asymmetric encryption also when in type of phishing activities. But you may not get into that as a technical person. You can understand whether you are using a real domain or a phishing website like that. But suppose some kind of a people will be there, non-technical people, they are like functional people. They don't know what is domain, whether it is, but look and feel anyone will see, right? But they thought okay, this is also same, looks like that banking application only, like that. But these type of things also will happen. This is called as a hacking, phishing, these type of things. But how to handle this scenario? How to handle this scenario? Here we are going to use something called CA. There are we are going to get the certificates. Whatever certificates we have generated, right? Whatever certificates we have generated, we are going to get signed these certificates from some CA. There is something called CA, certified authorities, who are going to sign this certificate or issues the certificates for us. So before these certificates are being used for exchanging the data, decrypting, this we are going to request some kind of a certified authorities. We are going to request some certified authorities. We are going to request some kind of a certified authorities to issue some kind of a certificates, sign these keys and issue some kind of a CRT file, certificate file, some kind of a digital signature. We will get it done. So we have so many CA, certified authorities, who can issue the certificates for us, like a DigiCert, Let's Encrypt, right? Venafi. There are some kind of a certified authorities. So we will get these keys signed from that certified authorities. When we are going to request, there is something called CSR, certificate signing request. We are going to generate some kind of a CSR. Once we have these keys, we are going to contact some CA, certified authorities, like Let's Encrypt, DigiCert, or OpenSSL, DigiCert or OpenSSL. These type of CAs are there, certified authorities, who can issue the certificates. Who can issue the certificates. You are officially registering these certificates I have generated for this application, like that. Just to give an example, suppose as a couple, suppose you are getting married, you are officially getting registered your marriage in some kind of a registrar, right? Like officially you are registering, yes, so and so persons got married, like that officially you are registering. Similarly here, this is like a key, private key, public key you have generated for some application, some system or some application. So you are going to get these certificates signed or signed using some kind of a CA, the trusted certificate authorities, who are going to sign these certificates. So whenever you are getting that you are going to request, a CA to sign this certificate, digital signs. So there is a concept called CSR, certificate signing request. When you are requesting that certified authorities, when you are creating a CSR, you are going to tell for which domain or for which application you are trying to get these certificates signed, like that. So when you are contacting that CA, like certified authorities, like Let's Encrypt, DigiCert, Venafi, GoDaddy. In AWS also there is a CA, certified authorities, who can issue or who can sign these certificates. So when we are creating a request, a CSR request, certificate signing request, we are going to tell, I am going to use these certificates for some domain, some application. Suppose my domain is this one, let's say. My domain is this one, Rushi Technologies.com, right? Or maybe subdomains also you can tell, maybe this one or this one. These are my domains. I wanted to serve my application using these domains, like that. Instead of IPs, you are going to pass the domain names only with this CA. So you can say star also. Star means any subdomain, star.rushitechnologies.com. That star can be anything, like a mail.rushitechnologies.com or a jenkins.rushitechnologies.com, nexus.rushitechnologies.com, like that star subdomains. So when you are going to create a CA, I mean to say CSR, certificate signing request, you have these keys and you are saying, I wanted to use that keys for this application or this domain, like that. There is certified authorities who can issue the certificates, like as I already saw, certified authority CA. Let's imagine there is a CA, certified authority, certified authorities, certified authorities. There is a CA here, certified authorities who can issue the certificates, right? So here, these certified authorities, what they will do, they will take your certificates. They will take your certificates while you are creating a request, while you are creating a CS request. So they will include your public key. They will include your public key in that. They are going to give some kind of a certificate. We call it as a SSL or a TLS certificates. SSL or a TLS certificates. So they are going to include. They are also going to give one certificate, one kind of a key. Again, they are also going to give one kind of a certificate file, CRT file. There is something called CRT file, certificate file. So they are going to give one kind of a key. They are going to give one kind of a key that is called as a CRT file, certificate file. So what they will do here, what they will do here, your public key will be included, and they are going to sign. They are going to sign, I am issuing this certificate. I am issuing this certificate for this application or this domain, like that. That domain name will be there. There is a digital signature also signed by this CA, and they are going to include that for which domain they have issued this certificate. In this CRT file, in this CRT file or a certificate file, there will be a public key, there will be a public key, plus there is a signature, digital signature given by this CA. And also in this there is a for which domain they have given this certificate, right? That domain details also will be there, whether they have given for this domain or something else like that, whether they have given for this domain or something else like that. There will be a domain name also for which domain they have issued this certificate, like that. Now this is the certificate issued by this CA. Now when any request comes to this server, now this is going to extend this certificate. This is called as a server certificate. This is called as a server certificate. In this certificate, in that certificate, there is a public key, there is a digital signature given by this CA, and for which domain that certificate is issued, which domain or which application. Now this browser will not directly use this key to decrypt. I mean, say encrypt. See, my voice is breaking for everyone. Is my voice is breaking for everyone? Okay, let me see. What is the problem? So, 1 second, guys. Let me see. Is this fine now? I mean, are you guys able to hear me? Is this fine now? No, it's good. Okay. So what I am trying to say here now, there is one more trusted person, trusted company, or a trusted authority will come here to verify both parties are correct parties or intended parties, only, like that. So here, this CA, certified authorities, will take this. They are going to use the public key and they will sign. They will sign. There is something called digital signature. They will give one key, like certificate key. In that certificate file, SSL or TLS certificates, we call it this. In this certificate file, there is a public key and also digital signature, and also there is something called basically your domain also. Private key issuers, or we call it as a CA, certified authorities, like that. Then when any request comes to this application, they are going to give this certificate to the client. Here there is a public key signature, but this browser will not directly use this key to encrypt the data and send. This browser will do some kind of a verification again. Is this key is given to that server or that application or not? So how that verification will do? This browser will again contact that CA. In that certificate, the digital signature is going to there, and the domain is there. In that digital signature, there is a, I mean to say, who issued this certificate for them. That is information also there. Which CA, which certified authorities has issued that certificate to that application. Whether they have, this is issued by Let's Encrypt, whether this is issued by Benafi or GoDaddy or IGCert, like that, that information will be there. This browser will contact first this CA and it will verify. I got this certificate from this application. I got this certificate from this application. I got the certificate from this application. So is this certificate is issued by you for the domain or not? So this will say, once some issue. There's some network issues there with my internet provider. Let me use. Okay, let me share my screen. And I have switched to different network. I hope now is it clear? My audio, video. Can you guys confirm? Is my audio fine? Video fine? Okay. So now, what I was trying to tell here is whatever certificate issued for that application or a domain by this CA. So these clients will first contact this CA. I mean, say that browser will do. That browser will contact this certified authority. This certified authorities to cross check whatever certificate I got. That certificate has public key and some digital signature, and that for this domain like that. So is this certificate you issued to this application or this domain or not? So if this is issued by this trusted person, this trusted party, yes, they will confirm, yes, this certificate is issued for this domain, for this application by me only. So you can safely use that certificate for communication exchange like that. Then here there is a key with the certified authority also. Then this person can use this key, and they can encrypt that key, encrypt the data, and they can send the data, and this server can decrypt the data using its key like that. So here we are going to use something called SSL and TLS certificates or a protocols, right? SSL or a TLS or a certificates or protocols to secure the information again using these type of concepts. So here there is something called SSL and TLS. What is that SSL or a TLS? Or what is SSL or a TLS certificates? Right? The SSL stands for Secure Socket Layer. That TLS stands for Transport Layer Security. You can think of TLS. You can think of TLS as a you can think of TLS as a successor of SSL latest version. You can think of TLS as a successor of SSL latest version. Nowadays, people say SSL, but basically nowadays most of the people are using the TLS certificates and TLS versions, cyber suits to exchange that type of data. So here we are going to generate our request. We are going to generate or request these SSL and TLS certificates from these certified authorities, and we are going to configure. We are going to configure that SSL and TLS certificates in our system so that any request comes to this server or application, we are going to use that certificates for encryption, decryption, like that. But this decryption can be done only by this key only, private key, and the public key is used for encryption. But why this CA comes into the picture? Very to verify this person is also correct person. I mean, say, is this system or application is the right system to which I wanted to interact, like that. So here there is a concept called self-sign certificates. There is a concept called self-sign certificates. You can also generate the certificates, and you can also sign the certificate self-sign. But if you are using self-sign certificates, then again the browser will not trust those certificates. The browsers will say you are using self-sign certificates. Again, using the application, even though you are using an application with HTTPS protocol, even though you are using a certificates, but that is a self-signed certificates. Self-signed means we are only signing that certificates. So that self-signed certificates, again it will work with HTTPS, but that browser will give some kind of a message or a warning saying that that application is using self-signed certificates. Be aware of that. That the certificates are not trusted or not verified by any CA, certified authority. That time browser will give warning, but you are going to ignore and again proceed like that sometimes. But most of the times for real applications you are going to use HTTPS with not self-signed certificate, the certificates that is get it signed from some CA, certified authority. If you see any application nowadays you guys are accessing, suppose you take Flipkart. So here in the browser you can see this type of symbol, we call it as a padlock symbol. Here here you can see there is one type of symbol. Here if you click, it is going to say connection is secure. Connection is secure. And if I click this, connection is secure, certificate is valid. Your information, for example passwords, credit cards, is private when it is sent to this site or application. Certificate is valid. If I click this, you can see this certificate is issued to which application or a domain, like Flipkart. This is issued for this, right? And which organization, this is like a common name. That common name or like a domain name. Organization means that company name, Flipkart Internet Private Limited. And who issued the certificate for this domain, you can see there is one organization CA. This is called as a CA, issued by Global Sign. Global Sign, SSL CA. And in this certificate we have so much of information: certificate, public key, like that. This is like a digital sign, and this is the public key of this domain. And again here so many details will be there, like for whom this is issued, like all these versions, like which type of who is the issuer, and what type of encryption they are going to follow, all these things, certificate and public key. This is like public key of that Flipkart. Like that, all these things are there. Similarly, you take any application, even Google, Facebook. You can see connection is secure, certificate is valid. For this one, Google Trust Services, Google itself has the CA. They are issued like this. We have some kind of a CA, certified authorities like DigiCert, Venafi, Global Sign, Open SSL, Let's Encrypt, like that. There are so many. You can get it certified from any of them. Now there is something called SSL and TLS handshake. There is a concept of SSL and TLS handshake. When the connection or communication is initiated, before they start exchanging the data, some kind of a handshake will happen to verify both are a trusted persons or not, like that. There is a concept called SSL or TLS, basically handshake. SSL or TLS handshake. So here basically there is a process before they start exchanging the data. There is some kind of a communication will happen. So this client will send this client means this is like like a user. This is going to contact this server. This is going to contact this server for accessing the application. This server will tell, I am going to communicate with you using HTTPS protocol, and this is my certificate. This is server certificate will be given to this. Here, here again, basically in phase one, deciding which version of the protocol to use, the system decide which protocol to use. Client and server will exchange some kind of a hello messages with each other to confirm which kind of a SSL or TLS versions they are going to use for exchanging the data, and they are going to agree, these two parties will agree which protocol to use. This will say, when this is contacted, this will say, I wanted to communicate with you using https protocol, and again HTTPS protocol, and this will say, okay, I am going, my browser or this system will support these and all the versions, like SSL version, TLS versions, which versions I can support also, that type of information will be given. Then this server will send the certificate, that the certificate got from the CA. The server will send his certificate, and it is going to exchange the certificate to this one. Then verification phase. In phase 3 the client will reply to the server by sending his certificate, that is called as a client key. But this client will exchange his key when, after verifying with CA, whether this is a certified authority, this certificate issued to this one is a valid certificate or not. After that, this is going to send, the client will send his key, and it will exchange. So here both parties will do some kind of a verifications with each other, then that handshake will complete, then only the communication will started. There is a concept called SSL or a TLS handshake. Basically it's like a some kind of a exchanging the keys and trusting each other. After that only the actual communication will happen. So here we have a client hello, server hello. That server will exchange the key. Client will say hi to server, like that. That is how it works. The client will initiate the process by sending a hello message to the server. This message includes what versions of TLS or SSL it can support, that browser or that system can support, and what type of algorithms the system can support. This server will send hello message back. Again, appropriate SSL and TLS versions it will choose based on what versions client is supporting. Then it will also send the digital certificate that contains the public key of that server. Then the server will send the message that includes the certificates and public key and a client key. Client will verify the server certificates. Client will verify. How that verification will happen? It will contact the CA, certified authorities. Then it will use as the server's public key to encrypt the data. It is going to use some kind of a encrypted pre-master secret, some kind of a random number it will encrypt. Then the pre-master secret is used again for all further encryption and decryption, like that. This whole process is called as a SSL or a TLS handshake. But now whatever application I am accessing, it is not HTTPS enabled, and we have not used any keys. If required, as I already said, you can generate your own keys and you can get signed yourself. That is called as a self-signed certificates. But again, if I'm using a self-signed certificates, then this browser will give warnings to the users, like this is not a certificate issued by some official CA. This is self-signed, like that. Now we will generate the certificates, and we will request some kind of a certified authorities to give the certificates for our domain, and we are going to configure them at the reverse proxy or a load balancer. And here, if I'm configuring that certificates here at the reverse proxy to secure the communication between these. So here in the public network like internet, the data will be exchanged and sent in a ciphertext format. So before the data leaves this client system, using these keys it will encrypt the data and send to this, and using this key the server will decrypt the data. Here there is a concept called SSL and TLS setup. You can configure those certificates here, and there is a concept called SSL and TLS termination. If required, you can terminate that SSL and TLS here, means decryption. This itself can decrypt the data. From here to here data will come in HTTPS protocol, and from this load balancer or a reverse proxy to your actual applications it can be HTTP also. But this is okay, fine. How it is fine? Because this is like an internal network. So from here to here only public network, from here to here only public network, but from here to here it is like a private, our own network, local network. Here it can communicate on HTTP also fine, like that. SSL and TLS termination will happen, that decryption will happen here, and the decrypted data only will be passed to these servers where our application is running, like that. If required, internal communications also you can secure using certificates again. If required, internal communications also, if required, you can configure certificates again for internal communications also. This is the whole process of encryption, decryption, that concepts, ciphertext, cryptography, all these names you should get familiar. Now I have not requested any CA to give me a certificates for my application or a domain, and I have not deployed. If required, you can request from some kind of a CA, certified authorities. That can be like there are so many certified authorities like Zero SSL or Let's Encrypt, like that. Suppose there is one organization called Zero SSL, and this Zero SSL is giving the certificates for free for 90 days, but in real time the certificates will have a validity for 1 year. Again, you have to renew or rotate that certificates again every 1 year or every 13 months you have to renew. But in order to understand these concepts, you can use this Zero SSL. It is going to give a free certificates, but that certificates also chargeable, guys. But this Zero SSL, or you can use Let's Encrypt also. You can use a Let's Encrypt also if required. That Let's Encrypt also will generate some kind of a certificates for our applications or domains, and you can configure those certificates in your load balancers. Suppose if you are using a cloud like AWS or Azure or GCP, they also have a CA. You can also request with them. But for now, you can use Zero SSL, or you can use Let's Encrypt, like that. Suppose if you are using Let's Encrypt, there is a CLI command line. There is something called cert board. There is something called cert board. So that is one type of CLI. Using that CLI itself, you can request or you can operate, or you can request the Let's Encrypt to give the certificates. Using that CLI itself, you can renew the certificates also. There is something called cert board. Cert board. So this is basically a CLI. CLI. So this, using the CLI cert board, is one software again. Using this, we can request some kind of a certified authorities. You can request some kind of a certified authorities to issue the certificates for our domain, and you can configure a auto renewals also. This is like one kind of a CLI cert board. So we can use this cert board also, a CLI, to request the certificates, like with a Let's Encrypt, something like that. Otherwise, you can use GUIs also, like free SSL. Here you can create an account. You can request this. You can enter your domain, for which domain you want a certificates. Then it is going to perform some kind of a validation also. You have to prove. You have to prove you are the owner. You are the owner of that domain again. Otherwise, anyone can request the certificates for any domains, right? You can, there is something called a DNS challenge. So you have to prove that you are the owner of that domain. How that verification can be done by the certified authorities again? By creating some kind of a records, by creating some kind of a records in DNS. You can prove if you have a permissions to create a records in DNS, then you are the owner of that domain. So that type of verification will be happening here. The process here is, First, you are going to enter your domain, for which domain you want a certificate. Then this will generate the CSR, certificate signing request for that domain, and you have to do validation, one step validation. That validation is you are the owner, or you are the owner of that domain, like that you have to prove by requesting, by creating some kind of a records in your DNS. You can prove that you are the owner of the domain. Then the certificates will be issued. Once the certificates are issued, then you have to take those certificates and configure those certificates or install those certificates in your like a load balancers. That can be software load balancer, hardware load balancers, or that can be a container. Suppose you are running a software load balancer also as a container, also you can configure those certificates like that. You can use OpenSSL, or you can use a Let's Encrypt. If you are using Let's Encrypt, there is a CLI, easy to do also. There is a Sudbot. You can use that Sudbot for you can install one software called Sudbot CLI. You can request using CLI by executing some commands like that. Otherwise, you can use any type of also, but this is something. Each has a different concept. Suppose I already have a domain here. I already have a domain here. Like this 0 SSL. I mean, it's not domain. I already have an account with the 0 SSL. Here I can log in and I can create a request here. So let me log into my 0 SSL. You can use any CA, but the concept is same. But the way you are going to do may be little different, but the concept is same. Suppose I am log into this. I already have an account. I am just log in to this. So here, this can issue certificates, only 3 certificates for free of cost. In every account, you can take only 3 certificates for free of cost. You can take only 3 certificates for free of cost. Again, that certificates is valid for 90 days only, because we are using for free. But paid, it is not like that. You can request unlimited certificates if you have so many applications. And again, if it is not free, paid, right, then the certificates will not expire very fast, right? 90 days expiration only they are giving for free. Again, only 3. Suppose here you can request new certificate. Here once you log in, premium means paid, it is not free. So here free certificates also you can use. I already have 2, but if request, I can do like this, new certificate. Here you can give a domain name, for which domain you are trying to request the certificate, and that keys also it will generate certificate with that private key also it will generate. Otherwise, if required, you can generate your own private key, that key pair, and you can tell use this key also like that. Otherwise, you can let this certified authorities only to generate that private key also along with certificate. So here I am going to tell my domain. This is my domain, rushitechnologies.com, like for this one and this one. But they're not going to support wildcard certificates for free of cost. I'm not generating. So I have given my domain. For this domain, I wanted to get the certificates. Click next. Here 1 year certificates is not for free of cost, so I'm selecting 90-day certificate, just for understanding or learning concept. Next step. Here again, if you are using any additional, again they are going to charge. So I am not selecting any add-ons. I want free certificate only to explain this concept. Next, auto generate CSR. So here you can select auto generate CSR. So what it will do, it will automatically generate that CSR, certificate signing request, and also it is going to have the keys, that private key also generated, and it will give me everything. So click on next. And what algorithm, that key, private key, maybe you can go with RSA 2048, maximum compatibility will be there, RSA algorithm, like this. Click on next. So free, anyhow free, right? This is free only, by default it is selected free. Click on next. It is going to give me one file, one type of zip file. But before it is going to give me one file, that zip file, where that private key will be there, certificate will be there, like that. First I have to prove that I am the owner of this domain. So you need to verify the ownership of your domain before you use this certificate, because anyone can request certificates for any domain. So I have to prove that I am the owner of the domain, or I have the permissions to manage this domain. Here there are multiple options. One is email validation, another one is DNS validation. So I will go with this DNS validation. I will go with this DNS validation. I will go with this DNS validation. Then here I have to create one record in my DNS, that name servers. The way yesterday I have created a record, alias record, in order to prove I am the owner of this domain, or I have a permissions to manage this domain. In that DNS, I have to create a record of type CNAME with this as a name, this as a value. So anyhow, I have a permissions to manage the domain. So here in GoDaddy Route 53, I will create a record of type CNAME. Record of type CNAME. Let me log in. So here I can go and create one record, create record, type instead of C, A type, I am going to take C name, and this as a name here, record name, this as a name, this as a name. But already there is a .rushitechnologies.com. In this, you no need to give this last one, just remove that, take this. Here already, if I am going to enter, it is already there. This will take like this. So I have just given this as a name. Value is that entire value, to prove that I am the owner, or I have a permissions to manage that domain, like that. I am creating a record. After this, let me come back here. Then click on next step, and this is going to check that is that the record is created or not. Next step. Now here we can click on verify domain now. Verify domain. Now this is going to contact that DNS records, and it will, if you see that that record is there, then it will confirm, okay, you are the right person. You are the person who can who are managing or owning that domain, like that. Then after this, you can download the certificates. Basically, it is going to download as a zip file, like that. So here you can download in whatever format. Suppose you wanted to download for Nginx, you can select like this also, Nginx download certificate, this zip. Click on this, it will download a zip file that is downloaded to my local system. This I can upload, this I can upload to, I can copy to that Nginx server first, there I can configure. But if I am using certbot, if I am using a certbot, like that, there is a CLI, you no need to do all these things. Via CLI itself, we can contact that certified authorities, and that itself will generate and create certificates, and we will get the certificate verification also done via CLI only, like that. That is very easy also. But since sometimes you may use these type of things also, I'm trying to explain this. Now I got that zip file here. This zip file I will copy, this zip file I will SCP to that server, server. Maybe let me rename this, this is like a latest one. Now this is the zip file that contains some kind of a CRT file, CRT file, file, like that. Now let me go to my command prompt, and I will copy my local system. I have that file. I will copy to that server, that Nginx server. I will copy to that Nginx server. This server I will SCP. So let me take public IP. So in my local laptop I have SCP. The PEM file I will use for SCP also you need a PEM file. So what is the PEM file name? Okay, this is the PEM file name. That PEM file I have for here, and this one I have to copy this file, this zip file that has that this zip file, this sorry, this zip file I will copy from my downloads folder. I will copy to this system EC2 user at the rate. First I will copy to the home directory, later I will copy somewhere else. So first let me, IP address is this of that server to the home directory, home EC2 hyphen user. Let's copy this. Now I will SSS to that server also. Now I will SSS to that server, SSH hyphen I EC2 hyphen user at the rate that system. Now here I have that file. I will unzip this. I will unzip. Maybe what you can do, sudo or normal unzip also. Unzip. If you don't have unzip command, you can install that unzip software and you can extract. Now I have this private key also, that certificate and certificate bundle like that. We have three files here. We have a three files here, and here they are going to give some kind of instructions also, installation. So installation also they are going to give some kind of a instruction also they are giving. They're giving some kind of installation instructions also. So follow these steps, download your certificates and follow these steps like that. Basically here they're telling how to install that also, right? So in this article you will learn how to install SSL and SSL certificates in your Nginx to set up a HTTPS. So before you start, make sure you have downloaded that certificate files, right? After downloading your zip file containing these three files, right? First you upload that certificates. Upload means you copy those certificates to Nginx server and wherever you wanted to. So I will create some folder where I will copy these files. But Nginx requires all CRT files to be merged in order to allow SSL installation. So they're saying you execute one command like this. You execute one command like this. We have that CRT bundle dot CRT, this one. So whatever there in this also, you are including that to this file. Already some data is there in this certificate. Again, you are going to include whatever it is there in this file also. That's what they're giving some kind of an instruction. This also they're saying there are this also you wanted to include also, if required you can include like that they're giving. This is you can do in the same directory, but later I will copy. Redirection you already know. Now you copy these files into some location, secured location, not in the user home directory. So I have a Nginx in this etc. I have a Nginx folder. In this Nginx folder I will create some subfolders also. In this Nginx folder I will create some subfolder also like this, mkdir -p /etc /nginx ssl. Under that ssl again, if required, I will create a folder like Rushi Technologies .com, some folder name, that's it. Rushi Technologies or Rushi Technologies.com, whatever you would like to give, you can give Rushi Technologies.com folder name, or without .com also. So normal user don't have a permission, I will use sudo. Now I have a folder. I just have a folder there, but I don't have anything now. I will copy this to that location, whatever I have now. So in this I don't have anything, but I will copy these three files to that location. So normal user don't have a permission. Let me use sudo cp this file, and these three files I am trying to copy to this folder. This folder. Now you see that folder. That folder has those three. The folder has those three files. right? The folder has those three files, and make sure these files are owned by root. No one else should have a permissions also. I think we already have a root only. The root only has the permissions on this because we used sudo already. So root owner is root, right? Root like that only. You can see permissions also there. Now in your Nginx conf file, now you have to start accepting the traffic on 443, not on 80. 443 secure port. Now in your Nginx conf file, that reverse conf file, you are going to tell listen on 443 and use SSL certificates now. And SSL is on, you are going to give the path. You are going to give the path of that location where we have that private key, that CRT file. So using these options in your Nginx conf file, you are telling now, I have to serve this on HTTPS, not on HTTP. So start accepting the traffic on 443, and I am enabling this SSL. This HTTPS protocol 443 is HTTPS. This HTTPS protocol listens on 443. I am telling now load balancer to listen on 443 and accept the request on HTTPS. And when we are using HTTPS, we are giving the location of the CRT and keys like that. Now, whenever request comes to this load balancer on HTTPS, this is going to send this key, this CRT file. That CRT file has the digital signatures, that public key like that. Then the private key is staying within the server only. Then any data exchanged using that public key and comes to the server, this using this private key, it will decrypt the data and understand. And again, you are going to mention some options like your domain. One more option like a server name, for what domain you are configuring these certificates like that. You are going to mention all these things here. You are going to mention all these things. But if you see in our Nginx conf file, in our Nginx conf file, whatever Nginx conf file we have in this etc Nginx, here I have already have a conf file. Now if you see, this is how it is there. This is how it is there. But here we are using, we are saying listen on 80, but I have not mentioned any domain name. If you see, I have not given any certificates, details, all those things like that. Now this I have to change to 443. And if required, you can still accept the traffic. If required, you can still accept the traffic on 80, but any request comes to 80, you have to redirect to 443 also you can do. So here you are going to update these files according to your requirement. Since it's a concept, since it's a training or a concept, first I have explained what is Nginx, what is a load balancer, what is HTTP. Later, now I am making the changes in real time while configuring itself. You will do all these things. Now I will give the notes also if required. Here, suppose here you are going to define like this. If you are using HTTPS, right? Suppose you have downloaded the certificates from you have downloaded like from 0SSL. This is what we have done. This is what we have already done. I have copied that certificates to that, and here we have done this one also like this. Then you can use this is how you can do. But in this 80 block, you can still accept the traffic on 80, but here we are returning redirection to HTTPS. So we are saying HTTPS. So HTTPS means it will redirect to this 443. This is what we are doing now in HTTP block. Now we are just telling these are my domains, and I don't want to process as is. I am redirecting this. 301 means redirection, redirecting to this HTTPS. So now I have a HTTPS block here. Here we are saying listen on 443 and HTTP, that HTTP2 on like that. We have some options. Then we are giving server name. Here you can give that location where you have that files, that key file, CRT file like that. Then here you are going to again tell any request comes on 443, forward that request to this upstream. This upstream means again these servers. But here from till load balancer HTTPS, but here it is again HTTP because we have not configured certificates in Tomcat, right? So we are just saying HTTP to this group of servers like that. So this is what we are configuring, and these are like options. suppose timeout option. Suppose this upstream servers is not responding within 60 seconds timeout. All these additional, and this already this yesterday also we have kept all these things. Like this, you are going to update your information here. But make sure you give the correct locations and correct details. Suppose these are my upstream servers. Now this is my domains, rushitechnologies.com, www also. But any request comes to 80, I'm saying redirect to HTTPS. So, but here I have a server block where I'm listening on 443, and for these domains I'm configuring these rules, and this is where I'm giving a certificates. But now I have in a different folder. That folder names you can see. This is where I have. So I can give like this also. But that CRT file, certificate file, this one, certificate.crt, semi, like this. And this certificate key, that certificate key is this one, private key, in the same folder. You are telling the yes, Nginx, these are my CRT file, that is signed by CA, and this is the private key, like that. So you take this, you take this, and replace that file. Maybe if required, you can take it as a backup also, that file, nginx conf file, in case if you wanted to use for future. Let me say, I will just copy. I will have it as a backup also, because in case in future again I wanted to use that. Again I will copy conf, simply like http.bkp, like that. Some kind of a backup like that. Slash is missing. So I have a backup file like that also. Now let me edit this file, sudo va. This file I will edit. Now I will make changes. If required, you can delete entire thing, and you can keep it also. If required, you can delete entire thing. You can remove and create also, fine. Now this is my content. This is my content. Now same thing. Now we have a HTTP also we are accepting, but it is not going to process. It is going to redirect. We are saying return. If any request comes to HTTP protocol on port 80 also, we are saying redirect. Redirect that to different. So you can see server section listen on 80, but we are saying redirect to HTTPS. Then any request comes to this port 80 also, now it will be redirected to this one. And here we are handling with the certificates, and if any request come, again we are proxy passing this to Tomcat, like that. This is how you are configuring SSL and TLS certificates here. Now let me restart this. Any changes you have done to that file, you need to restart, reload and restart, that settings are proper or not. You can verify also, like this. Sudo system ctl, like this. Now configuration is fine. Now make sure in your load balancer you have to open 443 also, firewall. If it is not opened, again request may not reach that for load balancer also, right? 443. So go to your security group of your Nginx. Go to your security group of Nginx. Go to your security group of Nginx, and you have to open that port also. Suppose let's say here, this is your load balancer. Go to security group. In the inbound rules, open that 443 port also, otherwise it will not reach 443 port for everyone, like this. Now you start accessing. Even though you intentionally type HTTP also, it will redirect. Whether you intentionally type also, it will redirect to HTTPS. Now if you see, here you can see padlock symbol for my application also now. You can see a padlock symbol for my application also now. You can see a padlock symbol for my application also. Here you can see connection is secure, certificate is valid. certificate is valid, right? Certificate issued for this domain, issued by this 0 SSL, 0 SSL RSA, but this is free I am using, so 90 days validity. Now any data that is exchanged between the client and server, now it is secured, encrypted and sent over network. So this is how you are using the application. So SSL and TLS concepts is different, certificates, domain concept is different, load balancing is different. But all these three concepts I have implemented. If you see, even though I have taken a sample application, there is no difference between the real application and our application. Concepts is same. But in this application, there are so many features. It is a business application, retail application. Here, so many modules are there, so many features are there. Here, you can log in, you can create an account, you can log in, you can search the products, make the payments, and you can track the orders. That is like a functionalities. But concept is same. The design and implementation might be different. The concept is same. Here also, if you see, there is a domain, there is a certificates, and there will be a load balancers, and in the background that load balancer is going to distribute the traffic to that application instances. That application instances might be internally talking to the databases where there is a data about products, orders, payments, invoices, like that. And again, this Flipkart application may internally talk to some other type of applications also, like payment application, payment gateways to accept the payments. And also it may talk to some other vendors who are going to supply the products also, like that. But the concepts is same, but application is different. That's it. Now is everyone clear the concepts that we should be aware, well aware of all these things? Servers, storages, networks, load balancers, security, all these things. Is everyone clear whatever has been done from last 4 sessions, guys? But automation again. So instead of manually building and deploying applications, you can use automation like CI/CD also. Whenever there is a change in the code, you can have a CI/CD pipelines also in place where it can take the code, compile the code, create an application packages, create a check the code quality, code coverage. If everything looks good, deploy that code, like that CI/CD. And again, infrastructure automation using Terraform, configurations using Ansible, like that. Now if required, you can use any CA also, but I have implemented using 0 SSL. Similarly, if required, you can use Let's Encrypt also. Maybe in order to make that Let's Encrypt and Sutbot also some kind of a concepts to make you more clear. Let me take this, let me revert this. I mean to say, again, I will revert back to HTTP only, and I will get the certificates from Let's Encrypt. You no need to get from two different CAs, but I am trying to explain that is even easy. There is a sudbot and there is a CLI. You can request the sudbot. With the help of sudbot, you can request Let's Encrypt to get the certificates. Then you can configure that certificates easily also. Maybe let me take that will not take much time. Maybe let me revert this. What I mean reverting means I will again this file, right? Whatever I have, this I will keep aside. I will take this and again I will revert back to normal HTTP only. I have that backup file. I have that backup file. So let me remove this file. Let me remove this file. Guys, if you are making any changes and reloading, if some syntax issues is there, it is not going to reload. Now I have removed, but I have a backup file. I have a backup file. In this, I have a backup file also, right? So I will rename MV in this Rushi Tech. This backup file I'm going to rename to normal, like this. Renaming I'm doing again. Now you see the content of this. Now it is HTTP. It is not HTTPS, like that. Here now there is no 443. We are not accepting 443. We are accepting 80, and there is no certificates, like that. Maybe if required, now you can verify also. If you access on HTTPS, it may say connection refused now, because that load balancer is not listening on HTTPS. It may say connection, but I have to reload. I have not reloaded that, right? It is there in the memory, so I will reload that. syntax I have done reload. That reload I will do. Now syntax is fine, reloading is done. Now if you start using HTTPS, it may say connection refused, because now I have reverted back my changes, and it is not accepting an HTTPS, and that Nginx don't know that information. Now I have reverted. Just to explain again, SSL TLS using Let's Encrypt. Now it will work on HTTP only, but a browser will be there. Now you can do maybe incognito window, or you can clear the browser cache and use it is working on HTTP now. But if required, I can use the certificates from Let's Encrypt also. There is a way to use the Let's Encrypt certificates. So here, if you are using Let's Encrypt, right, you can use these type of commands. I am trying to explain. You can use these type of commands. You can install that cert bot. It's a CLI, cert bot, a CLI. You can request the certificates using cert bot. I am saying I am trying to use with Nginx. We are telling these certificates I am going to use with Nginx, like that. These are my domains. I am trying to request the certificate. Now certificates will be requested and generated and saved in our system in these type of locations actually. Then these type of locations it will save. Then you can create a conf file, and here same thing, but now you are going to tell this is the key certificate, this is the location, like that. Again you can tell, but this is very simple. You can install certbot CLI, then you can request. Let's say I'm installing this certbot, then I'm going to request. So with the help of certbot, I'm requesting the certificates for my domain. So it is going to create a certificate along with private key also. Now it is generating, and it is asking me some kind of a input. Enter an email address if required in order to contact, but you can give any mail ID, that is fine. You can give any mail ID, that is fine. Now again it is asking, please read the terms and conditions. That's asking you to read the terms and condition. You can say yes, I have read, like that. Why? Press enter. Then they're asking any further information is you wanted to receive, like any news campaigns, advertisements, like that, because they're this is like a community. They're providing a certificates for free. They wanted to promote that company. They're asking, are you okay to receive any mails on campaigns, something like that. If you want, you can say yes. If you want n, no. Then it is requesting the certificates now with the C, that let's encrypt, and it is going to generate the certificate and stored. It is saying the certificates are generated and stored. Certificate is saved here, key is also saved here, but instead of CRT extension, they have a like a .pem extension. Fine. But here automatically also it can generate that server block 443 block, all these things. But in my conf file there is no server name where I have mentioned that domain names. That's why it was not able to generate, but manually I will generate. But this is the location where that certificate and key is generated and stored in this, that let's encrypt. Maybe you can move this to different folder also. Maybe you can move this to different folder, or you can give this path also. Now here, let's take that HTTP file. Manually also you can generate, or let's encrypt also will generate. Now same whatever I have used last time, same only, but here the certificate location I am going to give differently. That's it. Now again I am going to change that Nginx conf file. So here, so where it is generated, I have copied somewhere. So here let's take this file. Here I am going to give this path. Here this is the location where it has generated and stored in that system itself. Now in this location there is a, sorry, so let's see, /ls/etc, let's encrypt. There is something called live Rushi Technologies, like that. In this it has generated Let's encrypt. /etc. Let's encrypt live with our domain name rushitechnologies.com, like that. In that, again, this is one folder. In that folder you can see there is a file. This is like a private key, this is like a that CRT file, like that. So here you can give like this, that server private key, like this, that CRT file, like this you can give. Now again, let's take the same thing again, HTTPS to HTTP to HTTPS redirection also I am doing. But when we are using, you request for your domains, and here also you have to mention whatever domains you are configuring, that certificates, like that, also the server name block section. So let's take this again, I will update that file. I will update if required. You can take a backup for that HTTP file also, but if you don't want, you can leave it. Now let me remove that file. That file, this file I will remove, and I will create again sudo va /etc nginx conf d rushitech.conf. Now here I will paste this, but make sure you give all these options correctly. But there are a lot of additional options also that you can give based on your requirement. Now let's give like this. Now here you can give your server details, maybe 2 servers, 3 servers, upstream servers, you can give like this. So now this is the file where I have again listening the request or HTTPS, and here I have given my certificate location, key location, like that, and all these options. After making these changes, again you have to verify, right? You have to execute that command reload. You can do this type of reload. Now I am using certificates from Let's Encrypt. That domain verification automatically it is going to do internally. It will contact that DNS again. So that verification, fine. Now after that you start access again. Even though you use HTTP, now it will redirect to HTTPS. Let's do this. Control Shift R also you can use. Now again you can see HTTPS connection is secure, certificate is valid, but now you can see these certificates are issued by Let's Encrypt because I have changed that, like this. This is how again you can use. But you can use anyone like Let's Encrypt or Zero SSL or any other CA, but I try to explain both. Now domain is there, security is there, and load balancing is there. Now let's imagine load balancer algorithms, you can see round robin by default. Now one request going to one server, subsequent request other server, total I have a 3 servers. If you see now performance is good, you don't see any problem. Let's say I'm intentionally trying to stop some servers, I'm intentionally trying to stop, or maybe some issue with that application or a server. Again you may see performance issues, so slow responses, because there is so many servers are not there. Let's say I'm intentionally stopping, the load balancer will perform the health checks also internally. I'm intentionally stopping these 2 servers. After that you see very slow response it will respond, because there is only one server now, healthy server, like that. This I have intentionally stopped, but this can happen for any other reason. Application down, network down. So even the server is running, maybe process is stopped because of OEM out of memory, like that. Now you see, you start accessing the application. You are also the end user. Now you start accessing. Very slow response now. Maybe now it is there in a cache. Now you see refresh. Now it is still spinning, like that. You can see spinning. It is not loading. You can see spinning. Very slow. because there is only one server behind that load balancer. Very slow response it is coming, like that. So you have to troubleshoot, identify problems, resolve that problems. Whether server is down, even though server is down, is there a problem with network or firewall or application? Even though sometimes your application servers are healthy, I mean it's a running, maybe still sometimes it is not going to work. Maybe network issues or a firewall is not open. Even the server is running, maybe application is not running, like that. If all of the instances are down behind the load balancer, you may see 504 bad gateway, 502, 503 HTTP status codes. That based on the status codes also you should be able to troubleshoot, right? We already discussed 200 status code success, 404 page not found, 500 internal server error. Similarly, 400 bad request, 401 unauthorization, 403 access denied. Similarly, 501, 502, 503, that HTTP status codes. Sometimes you may see 504 bad gateway, 502 service, I mean, say timeout, 503 service unavailable, these type of status codes. So when we are using some kind of a reverse proxy, now you see this much time it has taken to respond. It is very slow response. I'm talking about something called HTTP status codes. HTTP, or that can be HTTP status codes. You can see 200 success, 300, 301 redirection. We are redirecting from HTTP to HTTPS also. Otherwise, from one application to another application also you can redirect. 301, 400 bad request, unauthorized, forbidden, not found. 500 internal server error, 503 service unavailable, bad gateway. Suppose this 503, 504 will be coming when we are using some kind of a reverse proxy or a load balancer like Nginx. If that reverse proxy is not getting any response from upstream servers, that time timeout gateways, this type of error. Or maybe this 503 also sometimes the servers are unavailable to serve the traffic, like these type of status codes. And when which status code will come, sometimes connection, I mean to say sometimes you may get a timeouts because of firewalls also. If a firewall is not opened in the application instance for a load balancer, even though server is running, application is running, if there is no network and firewalls are not opened, again the load balancer may not able to reach that servers, like that. So all these concepts is very very important. Now very slow response if you see. But let me start my servers again. But in my servers already I have installed Tomcat, and I have enabled a Tomcat as a service, and Tomcat on Bootstrap also. If I just start the server, Tomcat will be automatically started. You already know in Linux sessions we have discussed all those things. Now if this server also becomes unavailable, if again so many people access this application, again obviously that server will crash. That time all the servers are not available, again there is a application outage or a down. But if you are using cloud like AWS, there are so many ways. There is something called auto scaling groups, scaling policies, that we will discuss in further session. If anything goes wrong with these type of instances, that unhealthy instances can be terminated and created again by AWS. There is a concept of auto scaling group, scale in, scale out, dynamic scaling. And again, instead of manually creating this load balancer, right, you can use a cloud managed load balancer like ELB. So that is our next topic, right? That we'll try to understand in the next session, right? That is in our regular training. We will try to understand that ELB, auto scaling, those concepts will continue. But these sessions I am uploading to YouTube so that some kind of a people community also they can understand all these concepts. But tomorrow onwards that sessions will not be uploaded to YouTube. Only these 4 sessions I have uploaded, so that anyone who already have some knowledge they can understand this concept. But in cloud like AWS, instead of you create this type of load balancer server and maintain this, suppose if something goes wrong with this load balancer itself, if something goes wrong with this load balancer itself, again if there is no so much a traffic again coming via load balancer, again this may also have a problem. That time if load balancer itself has issue, again application is not accessible. And instead of you create a load balancer, instead of you maintain and manage the availability, scalability of this load balancers, right? Scale in, scale out the load balancers also, instead of you take care, instead of you install and manage that load balancer, cloud can manage for us. That is called as a cloud managed load balancer. In AWS we have something called ELB. So that is a little different. How to use ELB we will discuss, and also further concepts in AWS like auto scaling groups and other concepts we'll try to continue. So now let's see if all the servers are healthy. Now again, my application should be little fast. Now you can see you don't see any slow response. Again, you can see here I have kept the server IPs to make you understand the algorithms. I have used round robin, but if required, you can configure different algorithms also in your load balancer, as I already said in the previous sessions. Right here, you can use least connections or a sticky session, weightage. We already discussed about all these things. So try to understand, try to practice whatever has been explained. Okay. And if you don't have a domain, don't do anything with the DNS, and don't request any certificates also, because you should have a valid domain. So if you don't have a domain, just understand by going through these recordings. But if you have purchased some domain, maybe for small price, maybe you can practice all these things. Otherwise, without a domain, you can just understand these concepts. Okay, whatever I have explained. Suppose if you don't have a domain, but if you are using like a local host file, suppose you are creating some kind of a name and a mapping with IP, that is local domain, but certificates and all those things will not, you can't request. Whatever names you are mapping in a host file, local host file, you should have a valid domain, right? So understand the concept if you don't have a domain, but if you have a domain, you can practice also. I hope now everyone is clear how things works in actual projects or actual environments. So we have so many further concepts to be discussed, like a containerized deployments, microservices. We can build and deploy our applications as a containers, again that Docker, Kubernetes, again microservices architecture. So one after the other we are going to discuss in our regular training. But I hope now everyone clear whatever has been discussed. If you have any questions, any queries, feel free to unmute and ask. Otherwise, from here I'll continue tomorrow. Tomorrow onwards, we'll discuss about other concepts like a ELB, auto scaling groups in cloud. Anyone has any question? Let me know. All good. Everyone is confident now. What to use, how to use, which one is what. Okay then. Thank you. That's it for today. From here, I'll continue tomorrow. We'll see you tomorrow.